So I'm going to talk about Glimmer 2, Ember's new rendering engine. Does this sound all right? Yeah. Okay. So a little bit about me before I do. My name is Gavin Joyce. I work at Intercom. I have 2 intercomics. Everyone at Intercom each year gets an intercomic. Mine both have Ember-related things in it, which is cool. So I'm going to talk about Glimmer. Glimmer is, as I said, the new rendering engine for Ember. It's currently in beta, so if you install the latest Ember beta, 2.9 beta, it includes the Glimmer rendering engine. It's very likely that it'll be released in about 6 weeks with Ember 2.9. So a little caveat, I've worked on some of the Glimmer internals, mainly on the integration with Glimmer with Ember itself. So there's a whole lot I don't know and don't understand about the internals of the rendering engine, and there's quite a lot in it. But there is a decent amount that I do, and I thought I would talk about some of the things that I do understand. There's a million different directions that I could go in here, and some of it is, I mean, it's a very interesting project. I think it's the most interesting software project that I've come across. Feel free to stop me at any time and ask questions if you don't understand anything or you'd like me to go in a particular direction. So Glimmer 2, it's Ember's new rendering engine. It'll be released in about 6 weeks. It has many, many benefits. It's significantly faster, especially and crucially for initial render. So Glimmer 1 brought great improvements in re-render performance, but initial render was not really improved from pre-Glimmer. Glimmer 2 aims to solve that problem, and from working with it, I can tell you that it does solve the problem, and it's going to continue to get better and better. The templates are much smaller. As I'll show you, it's just an array of data. It's not JavaScript like all the previous templating engines in Ember. And because it's just data, it can be just-in-time interpreted. So again, for boot time performance, not having to process or parse or interpret a lot of code is a big win. So just a couple of days ago, I ran the latest Glimmer 2 beta on Intercom's app. Intercom, the company I work for, the app is, I guess we've one of the largest Ember apps. It compiles and gzips down to 1.3 megabytes of JavaScript, which is quite large. Uncompressed, it's 11 megabytes. With Glimmer 2 beta, that reduces it by over 30%. So it removes 4.5 megabytes uncompressed, and you can see the difference in gzip size, about 400 kilobytes, which is really significant. Importantly, this is just the beginning in terms of optimizations. There's a whole set of optimizations that are known that become much easier. And there's a lot of low-hanging fruit that will follow once the initial beta reaches release and beyond. So a couple of interesting things. By the way, most of this talk is going to be exploring the code and actually running Glimmer and looking at the stepping through the code. I've only got a few of these slides. But some interesting things, it's built in TypeScript. It's an implementation of 2 custom virtual machines. So one for drawing the initial render, so basically appending, stitching together DOM nodes. And the second for, once you have those DOM nodes and the data changes, updating those in a fast way. And I'll go into all those details soon. Like most things in Ember, it's also a drop-in replacement. So it's completely compatible with previous versions of Ember templates. It just takes handlebars and renders them using a new strategy. So some simple definitions of things we'll talk about. I never really did these things in college, so when coming to them, they seemed like big concepts. They're actually really simple. A compiler is simply a program that takes an input program and converts it into some output program. So that could be Java-C for Java, could be Babel, which transpiles, but it's also a compiler. Could be the TypeScript compiler. Even simple things like a JS minifier takes some source program and outputs an output program. handlebars itself, HTML bars, which is the current rendering engine, and Glimmer itself has several compilers in it. A parser is simply a program that reads input, usually text, and converts it into a more useful form, commonly called either a IOR for intermediate representation or an AST for abstract syntax tree. It's basically taking raw text and converting it into a structure that you can work with more easily. And a virtual machine is simply a program that runs instructions, runs programs. So Java has a VM, the .NET CLR has a VM, Android has one, and Glimmer has 2 in its runtime. So let's start with a very simple template. Handlebars template, it's got a paragraph with a static class called name. It's got a piece of text, hi, and a dynamic portion, name. So let's compare this in previous versions of rendering engines within Ember. So I'm not actually sure if Ember ever used raw handlebars itself, or handlebars if you go to like handlebars .js. So Yehuda Katz initially wrote this. I think we borrow the syntax. I'm not sure if this was ever used as the primary rendering engine, but it's useful to compare it. So I've removed some of the code here, but basically it just concatenates strings. So the compiler will take that, in this case, this paragraph here, it will compile it into a piece of JavaScript, and that will be the template that's delivered to a web application to render. So it takes some data hash, and it will concatenate a string, and it will escape the name to ensure that we're not susceptible to XSS. But it's very basic. This is pretty slow. It's slow for a number of reasons. String concatenation is somewhat slow, but if you start getting into recursive cases where you have a template that calls into a template that calls into a template, the slowness is very noticeable. But also, and importantly, if you want to re-render, you've no strategy other than regenerating the whole template and basically swapping it out. So HTML bars tried to improve that. I'll zoom out here because you can see a HTML bars template is quite large, and it represents the exact same thing. It's got some metadata which we can ignore, but it's got 3 functions that the runtime will call into. So the first is build fragment, and this will create a DOM fragment. So here it constructs a paragraph. Here it sets the class to name. Here it creates a text node. It stitches them. It appends them together. It creates an empty comment, and this is going to represent the dynamic name portion. And then it stitches those together. So you end up with a DOM fragment, which then becomes a template for creating real versions of this template and inserting it into the DOM. This create comment its purpose is to be a placeholder for the dynamic portion of the template, and the build render nodes function receives that fragment and the reference to the DOM, and it will actually create what's called a morph, which is a play on metamorph, which is from a previous version of Ember. You might remember the script tags from Ember 1.x. But it will create a morph, which is simply an object that wraps a piece of the DOM, and if you want to change a dynamic portion of it, it gives you a pointer into changing that part of the DOM. And then finally, there are an array of statements. In this case, it's very simple, and this is very similar to what we'll see in Glimmer 2, where it's like a bytecode instructions to actually run. So in this case, it's saying we want to resolve the name variable, and that's basically it. And I mean, it's obviously, if we look at the template, it's very simple. But this is slow for a number of reasons, and I guess we'll dive into it. But again, in the recursive case, it's especially slow. This was designed to solve a particular problem, which was re-render speed, which was sore point in Ember for quite a while. It was noticeably slow, and comparing to things like React, and you have dbmon as an example of that, it was just a sorry state of affairs. So this was a strategy to solve that particular problem, and it very much is optimized for the re-render phase. So you'll notice that the build fragment and build render nodes, once you've run them and you want to do an update, it's just a statement gets run each time, and it's only dealing with the dynamic portions of it. And this is what makes re-render speed actually very fast. We'll come back as we compare. We'll compare in more detail HTML bars and Glimmer, and I'll show you what the recursive case looks like. Here's what Glimmer 2 looks like. So it's completely a bytecode format. There's no JavaScript, which is important, meaning that the browser has to do far less work to actually understand what the structure is when it receives it. Also, because it's just data, it can be we can step through it and basically just in time process it. So when you boot an Ember app with templates that with a range of templates, but you boot into a certain root hierarchy, all the templates that aren't used, you don't have to do anything with it. It's just some data that's there. And as you move around the app, if you haven't processed this data, it will just in time actually process it. And again, we'll dive into what that looks like. So this is the Glimmer repository. This was a direct fork of HTML bars, which is also like a sister repository in the. So about a year ago, I think, HTML bars was forked and renamed into Glimmer, and this is what Glimmer is now. So it's a mutated version of what HTML bars was. So I also have the code here. And how will I do this first? First of all, is there any questions at this stage about anything that I talked about? Anything unclear? Okay. So I'm going to run two similar tools. One is from HTML bars, which is this, and one is from Glimmer, which is this. So these are tools that people working on the Glimmer and HTML bars runtimes our libraries use to kind of visualize what's happening. So this is the HTML bars version. You can see I can give it a template here. I can give it some data, and I can call compile, and it will create one of these templates that I showed you before. So this is, you can see it creates a DOM fragment, it creates a text node with hi, it appends them together, it creates an empty comment for the dynamic portion, it builds the render nodes, there's a single dynamic portion, and then it has statements. And we can compare that to Glimmer if I render the exact same thing. So you see it has the same name, same data, and the same template. And if I click render, it will produce a number of things. The first is the wire format. So this here, is that text big enough? Yeah, no? I heard a no, so I'll go for bigger. So as I showed you before, these two lines are directly equivalent to this whole nesting of JavaScript. So this is one of the simplifications and benefits of Glimmer. The templates are massively smaller. Sorry, I'm just realizing this is slipping. Okay, so there's a whole series of steps that I probably won't go into, but if you're interested, happy to talk about them afterwards, where this template is compiled into these statements. It's a series of parsing compilation steps that bring this, but it's not as interesting as the runtime part of it, which is what happens to the right here. So I'm not going to talk about the compilation steps, but this is an interesting place to start from. So you can see what this does here. There's a first statement which describes a piece of static text, and then there's another statement, append, which is saying unknown. I think this means that we don't know at the time of compilation whether this is a helper or a component or look up to some data in the context. So those two statements then get compiled at runtime. So there's a runtime compiler that the Glimmer runtime will get, which will compile it into a set of opcodes. So these are the instructions that will run on the Glimmer, the first Glimmer virtual machine. So this is basically a strategy for describing. Here's the actual DOM that we create. I mean, it's it's two text nodes put together. It's not very complicated. But these three opcodes describe an append-only strategy for drawing that DOM. So if I change the template to something more, a little more interesting, so well, this simply adds, like our first case, adds a paragraph to it. You can see that there are more statements. It opens an element, a paragraph. It adds a static attribute, which is has a class of name. It flushes that. It appends some text. It appends the dynamic portion, some more text, and closes the element. And that compiles at runtime to some opcodes for the append-only strategy of open a primitive element, add a static class to it, flush that to the DOM, append a text node, put a value, and we'll dive into what some of these things are. This put value actually means put it in a register in the virtual machine, which we'll look at. Then it cautiously appends that to the DOM. It adds some more text and closes the element, but without actually yet diving into how the virtual machine will actually process these, you can see that this describes an append-only strategy. Interestingly, there's a second virtual machine, which is called the updating virtual machine, which will run statements which are very similar to these statements here, which are the updating statements. So it also has an updating strategy. And this is just concerned with the dynamic portions of it. So this is saying we want to cautiously update, and cautiously means that the data may not have changed. So if we can cheaply check if the data has changed. If it hasn't, we don't do anything, so we don't touch the DOM. If it has, we will update the DOM. And that will be a single operation to reach into the text node and update its value, so blazingly fast. So let me just take a drink. Okay. So this Glimmer Visualiser is part of the, as I said, it's like it's a demo within, sorry, that's HTML bars. It's a demo within the Glimmer app itself. So it's Visualiser here. So we can use this as an entry point into stepping into the code. So I have the application here. In Glimmer demos, there is a Visualiser, and I put in some markers here. So okay, how about that? So there's not too much interesting about this application. It's a Glimmer application that uses Glimmer. If you want to, so a natural way to use Glimmer, the easiest way will be to create an Ember application, and Ember will provide all the hooks that it needs to use this new engine. These demos don't have Ember, so they construct a very simple runtime, or they hook into the interface into Glimmer. So it's got a bunch of data and a bunch of HTML, and it's like a very simple application. But the bit I'm interested in is when you click render and when you click update. Okay, so here is render. So this is the function that will be called when we click that render button, and you can see it parses the JSON data. It creates one of these test environments. It actually registers a helper and registers a component, so you can test them out. Things we're not that interested in, but then it compiles the actual template, which is something we could be interested in. I'll just drop a debugger in there. And then it will step into actually rendering this compiled thing. So I'm going to drop that debugger in here, reload the app. I'm going to start simple again, just with, I'll actually just start with high now, right? The most simplest template that we can have is completely static. So I'll click render, we're into our debugger. maybe that's too big. Okay, so you can see there's our template, and I'm just going to skip over the compilation step here, but look at what was produced. So we'll put it into an argument called, or a variable called app, and this is its result. So obviously we have a template here that's been compiled at runtime, but if you were in an Ember app, this would happen at build time. So this is the build time step that takes the handlebars template and converts it into the wire format, the representation that I showed you. This format here. So we should see that within it, it's got a block which has an array, statements array, and that's got a simple thing which is text high, right? So that's not surprising. We have a single instruction in the wire format which is text high. Okay, great. So that's our compiled version, and now we're going to render it. So I'm going to step into the render. Here it is here. Okay, so it's got a couple of things like what the outer div that we're appending to is, what self is. You can see the data is in there. It's got things like tags and references, which we may or may not get to talk to, but I'm going to link to some videos afterwards that does get into those details. So here's the first interesting step. It's actually going to do a runtime compilation, which is going to convert the. Here, let me do this in a separate one so we can actually see. So this is the wire format which we saw. It's now going to go through a compilation step, which is going to convert it into a series of opcodes. In this case, it's a one-to-one translation, so it's not that interesting, but I thought we'd start simply. I'll skip over this function for now and just get the result. We may come back to it if you're very interested in it. We can step into it. But you can see it's compiled into a form, a runtime form. It's a linked list. It's got a head, which you could, follow down next. It's a doubly linked list. But in this case, it's only got a single operation. It's text. It's called text opcode, and it's got a text value of high. So we're now going to take our single opcode, and we're going to execute it in the VM here. So this is the, as I said, there are two VMs. This is the appending VM. It's designed for drawing a DOM hierarchy by appending things. So I will step into that. Okay, and it does a bunch of bookkeeping in terms of like the frame that it's in, and a frame is like the current context. It's very similar to like the stack in JavaScript execution, that you could have a stack of different contexts, and as you process it, you move from stack to stack, you push and pop. It has things like that. It has an element stack, which is capturing the current hierarchy of what you're drawing. It's got a current frame. It's got a frame stack. And we'll skip over some of that stuff because the most interesting thing, I think, is when the opcodes actually get to execute. But this is just a bunch of bookkeeping that is the current state of the machine. So here's the while loop. So while we have opcodes to execute, so we're going to get the next statement. So this is the first time now that we actually have an opcode. As I showed you from before, the opcode that we're going to execute is called the text opcode. So if I step into this, you can see that we're within a text opcode. And I'll just switch back to Glimmer for a second, and you can see that this is using TypeScript, but here is the text opcode. That it's quite simple. This is really the important bit, the evaluate. It's given a virtual machine, which is all the state, and it will basically append some text to the current stack. So you can imagine what this is going to do. I mean, it's got a simple job. It's to create a text node and append it. So if we follow this in, there's the element stack and then append text. So we've now got the DOM. We're going to create a text node. Here's the text node, and you can see it's got, the node value or the text content is high. And we are going to, on the current stack, we're going to create a new node. So let's follow that in. Okay. Sorry, it was the statement before, DOM insert before, that I stepped over. So this is very simply taking a text node and inserting it into the DOM. And that's us done for that opcode. We have no more opcodes, so we're done. So that's the application rendered, and obviously it, renders high. Whoops. So let's take a slightly more complicated template. Every time it gets more complicated, I'm taking a bigger and bigger risk diving into the code because I don't fully understand everything. But let's do it anyway. So let's take this. So maybe this isn't that interesting. Okay, let's do it quickly. So this one. So there's our template and render. And this time, if we want to go to render, we compile, we execute our opcodes, and this time the compiled opcodes, you should see that we have a, again, it's a doubly linked list. It's got a open primitive element. So the first time we've seen this, so this is create a paragraph node, and then the next is a static adder. So we want to add a static adder of class, and it's going to have a value of name. And then we're going to flush that, which is to take all of the manipulations that we've done on that particular element and persist them to the DOM in one go, and then move on to the next thing, which is like, we'll actually step into it because I lost that. Okay, so let's go to, I'll actually just put a breakpoint here, right? So this is going to be our first opcode, and as we saw, this is create a paragraph. Okay, so on the stack, we want to open an element for paragraph, nice and easy. So we're going to this DOM that create that paragraph. We're going to do some bookkeeping on this is the thing that we're working on at the moment and return it. So we've opened an element. Okay, next statement. Opcode is add a class to that. Cool. So this is in the static adder opcode. So you think you can see like we saw with this text opcode that there are a whole series of different types of elements or opcodes which describe very simple steps on how to append or stitch together a DOM hierarchy. So in this case, what are we doing? Static adder, pull off some stuff. This is interesting because if it's got a namespace, we have to do one thing. If it doesn't, we do the other. So this is for SVG attributes which can have namespaces, and there are weird quirks in the DOM that you have to have different strategies. But Glimmer writes to the DOM, so it needs to handle all of that. In this case, we don't have a namespace because it's just a simple class. So we're going to this operations, add static attribute. Let's go into that. If it's class, and here you can see it's like as we get lower and lower, there are differences in how, intricacies of how you stitch together a DOM. Like I haven't seen this before, but obviously there's a difference with how you add a class and how you add a data attribute. So this is a class, and ultimately, I didn't see it there, but somewhere it's going to add that class. So this next opcode is flush. I think this is probably the bit that writes it to the DOM. Oh, sorry, I pressed the wrong button. I skipped over it. So let me keep going. Here's an opcode, another text element. We've seen that before. I'll skip over that one. This one is, did we do put value yet? Okay, so this is a dynamic portion. All right, that's right. We're coming from, I forgot. We just did high for the last one. So this is all new, right? So this is interesting because this is the first dynamic part of the template that we've come across. So let's have a look at the opcode. Well, it's called put value. It's got an expression in it, which is something called a compiled self-lookup, but it's got a parts array and it's got a name. So this is basically saying, in Ember you can have a dynamic portion. It could be, person.name, or it could be a.b.c.d, or it could just be name. So this compiled self-lookup is capturing that there's a hierarchy of lookups. In this case, it's the most simplest. It's just a single one called name. So that's part of the opcode. That was the job of the compiler to extract that data from the template and produce an opcode for it. So let's see what happens when we actually evaluate it, which again I just did. Okay, I'm gonna execute this all the way and then go back and do that again because I want to show you the dynamic port. Okay, opcode evaluate. So it's going to be at least a few in. This is flush element, text opcode. Okay, put value. So we're in the put value opcode and we're going to evaluate operand. All of this is pretty new to me. Like each time I step into something, I'm like, okay, what's this doing? But as you can see, it's pretty understandable. So we're going to evaluate an operand. We have this expression, which is the, if I can get this up, it's a self lookup with the part of name that we saw. So we step into that. We're going to set this operand on the frame. So it's like storing this lookup. Or actually, we're going to evaluate it, right? So let me see what happens if I execute that. Okay, so it pulls back a thing called a path reference, which has an internal cache and a property and a last value. And there's some really good docs in the Glimmer repository on what references are. Basically, objects that capture a value that you can pass around your application, and they're a construct you're able to compose together. So you can add them together. You can have arrays of them, or you can mutate them in different ways. And they've also got inbuilt caching into them. So if the value doesn't change, it's very cheap to just pull the value out of them. I doubt I'll have any time to go into it any more than that, and I actually don't know much more than that, but I'll point you to some good videos that do. But we have one of these references here, and we're going to set an operand on the frame. So this will, where are we here? Evaluate. Okay, this is the evaluate bit that I'll step over that. So now we're going to set the operand with this reference, and this is basically just going to put it on the frame. So we have this, the VM has an array of frames, and it has a current frame, and we've got a single frame at the moment, and we're on the first one. And we're going to set the operand, which I guess is null at the moment, and it's now going to be this path reference, this thing that allows us to go and pull that value of name off whenever we're ready to do that. So it's setting it up for the following opcode, I think. So that's that opcode finished. This next opcode is called optimize cautious append, and let's go into that. So it's just going to pick that operand that we put in the frame, pick it back up, and now it has that very same reference to name. It's going to normalize it, which I'm not sure what it is, but I guess it normalizes. I guess I've no idea what it is, but it gives us some sort of reference back. I guess we can just assume that didn't happen because we don't understand it. So it does a constants check. One of the cool things about Glimmer is because it has this reference system, it's able to tell if a variable that's passed around, and it could be passed through multiple layers, if it's constant or not. So it means that you could have a component that can sometimes take a dynamic property and it does something dynamic with it, but you could sometimes call it with a static string. So it could be like an icon component, and you pass in a static string, and the runtime will know you've got a static string, and it'll do a whole set of optimizations around it. It doesn't need to emit an updating opcode. It will never change, for example, but there's a whole other set of optimizations you can do. But in this case, it's not a constant, so we get a cache and we peek at it, so we get the value. So this is the first time we've actually pulled the value out of this reference, and you can see that's the name Ben that we got from our data. It's then going to do an insert. Where am I? Okay. An insert, a cautious insert. If it's a string, it does one thing. If it's a safe string, it does another. So, like in this case, it's just a string, right? So it's going to do this strategy. If it was a safe string, like triple curlies, or if we were to pass in a value that was wrapped in, HTML safe, it would do a different strategy, which I guess doesn't escape it. So we're probably going to find some bit of code here which is going to escape this value to make sure it's not. It won't escape it. It'll append a text node which will escape it. Or you can see we can actually pass it, presumably a DOM node here, and it will insert that DOM node directly. But in this case, we have a simple value of Ben, and we're inserting it. So it's going to use this strategy. And here you can see, finally, we're going to create a text node with a dynamic portion in it. We're going to insert it in a particular part of the DOM. You can probably see if we look at the element now that it's, this is the thing we're appending to. So it's probably got like inner HTML of hi Ben now, right? We're going to do some bookkeeping on the bounds and then return. So that's us done with, almost done. So we're almost finished this particular opcode. But interestingly, because this is dynamic, and you can see the check here, it's saying, there's actually a little helpful comment. If it's not a constant reference, then we need to do something else. And this is actually telling the virtual machine to create an update opcode. So this is like, it has two jobs. One is to draw the DOM, and the other is to create a program to do the dynamic portion when you want to do a re-render or when you want to update the data, which I think is really beautiful. So it's going to, I'll skip over this, but it creates an updating opcode, and I'm sure we can probably find it here. There's an updating opcode stack, and it's currently got a single thing, which is optimized cautious update opcode, which has that same reference to Ben, so it's able to tell if that value changed or not. It's got access to the text node that we just updated with the correct bounds and everything. So that opcode, when we run it, is ready to go. So that's that opcode done. Next opcode is a simple text opcode. It's a carriage return. Cool. Next one is close element. So, I guess we go into this. It's probably going to be very simple. Okay, VM stack close element stack, close the current element, pop the element. A little bit of bookkeeping. Onto the next opcode. Looks like we're finished. We're done. Okay. Interestingly, it's stopping again because, as I said, this visualizer is actually built in Glimmer as well. So it's running through the opcodes of actually drawing the UI now that we know what data is there. So I'm going to turn off that and actually just run right through it. So it's as you saw, we went through these opcodes. It drew this DOM, which is this HTML representation here, and you saw it emitted a single opcode for the updating VM to run, which we haven't run yet. And if we actually click update, it will run. So let's do that. I may have to put in a Let me just run it first. Okay, so I'm clicking update, nothing's happening. Okay, if I update Ben to be named 2, it'll say Ben 2. You can see that it's actually updated the opcode. It's got a reference. It understands what its last value is. So you can already see that it's able to do very little work if no data has changed. Let's put in a debugger in the updating part of this. So basically on this button here. Okay, so it's currently Ben 2. I won't change the data. I'll just click update to get the debugger. So we're expecting this to do very little work because the data hasn't changed. So it's going to call Rearender, which does a little bit of bookkeeping, but essentially we want to get to the execute updating, right? And this is another one of these. It's another program, right? It's a doubly linked list of opcodes. And you can see we have a single opcode, optimized cautious update. And as before, it's got reference to the DOM, and it's got reference to the actual reference that wraps the value of Ben. So let's step into that. And as I said, I'm even less familiar with the updating runtime, so this is going to be a surprise for me as well. Okay, so what does it do? It tries something. I'm going to skip over that for now. I believe that's to do with, well, actually, we might come back to that. Okay, so we want to get to the loop where it actually executes these opcodes. And we have, there's our opcode again, optimized cautious update. It has bounds, which points to the DOM. It has a cache, a reference, which has the value, and if it changes, it knows how to. We can ask it, has it changed, and we can pull the value off if we need to. So we're going to evaluate it. So it calls this.cache revalidate. Okay, this is like pulling the value off. Oh, I should have followed that in actually. So this is interesting. It returned this big GUID, which the next time I run this, we'll step into this, and I'll explain what that is. I'll explain what it is now. How about that? It actually is. There are certain values that this will return that will indicate if the thing has changed or not, right? So in this case, we're checking has it modified, and we internally will actually step into is modified, right? It's going to check this GUID, right? So that GUID is a special value that means something. But what that meant is for this opcode, and we only have one opcode for this updating program, it skipped over it. So it basically did no work, right? We're done. Okay, a little bit of bookkeeping, but that's it. So the whole update was basically doing nothing. Now, if I put that there again, and actually make a change this time. So we say ban and click update. So again, we're going to step into Rearender, a little bit of bookkeeping. I'm going to execute the opcodes, and again, we have a single opcode. This try, I'll skip over it again and come back to it next time. But here's our opcode, which is the optimized cautious update. We're going to evaluate it. This time when we get a value, you notice that it actually brings back, the value is no longer that GUID that represented that nothing's changed. It actually brought back a new value. And now when we go, is it modified? It has modified, so now we're actually going to execute something. So we have access to the bounds and like, I guess the bounds, the upsert captures the bounds. I guess this is the text node that we're going to update. There you can see the previous value. So we're going to call update. It's going to take the DOM, it's going to take the value, and if it's a string or something else, it does, it's different strategies. But in this case, it's a string, so we get the text node and we simply update it, right? So it's Ben. It used to be Ben2. That's the DOM updated, and we're done. And we do some bookkeeping with the bends. And again, that's it. So you can see that how little work that had to do to actually update the DOM. So both in the appending strategy and in the update strategy, there's actually very little work to do. If you actually were to draw out all the things you actually had to do to the DOM, that maps very nicely to the opcodes that represent those instructions. So there's, what time are we at? Okay, 8:30. So there's a whole other set of things which I know very little about, but they're in Glimmer. So things like components, they have a whole set of strategies for, when you call in to run all the insert element, all the different hooks that a component has. There are interesting things with, if statements and the blocks that they have. So I might actually just, I won't step through it, but I'll show you what that looks like. So in this case here, there's a paragraph with some text, and then a if name, there's a yes part of it and a no part of it. So if I change the template to be that, you can see that there's an actual block here. Actually, what we have here is the top level statements, and you can see one of those statements is a block that points into, says, if get name, so if it's truthy, then execute the block or the instructions at index 1, otherwise index 0. And you can see that the index 0 is the negative case where it says there, which makes sense. And the 1 is the append some text, append the dynamic portion, things we've seen before, and a new line, right? So this is how the blocks are handled. And you can also see that the opcodes are doing a lot more because it has to deal with a lot more dynamic portions of it. There's things like, we're entering a label or entering a section. There's a label, there's pointers to, which allow you as you're executing these opcodes to, if you want, blow away a whole section of it if you notice something is false, for example. So we won't have time to go into that, which I'm very glad about, because I think I would struggle with some of that stuff. But that's what that looks like. I think it would probably be interesting to compare, again, this, which is like these 8 statements that go over the wire with HTML bars. And this is, I mentioned one of the reasons why HTML bars in the recursive case, so this is anything with if statements or components within components or each loops, anything like that, why it fares so much worse than Glimmer 2. So like Glimmer 2, it has a concept of blocks. So you can see that actually we have child 0, child 1, and this thing here. So you can see here's a build fragment. So you can imagine the appending strategy for this, right? So it will build a fragment, right? It'll create a document fragment, create a P, append some text, hi, stitch them together, create a comment for the dynamic portion that's going to go inside there, and then stitch that whole thing together, okay? And then it'll call build render nodes, and it will set up the dynamic portion, create a morph for that bit that will change, pointing to that comment. And then it has statements that will run for the initial render and updates as well. And you can see this has a block if, something similar that we saw in Glimmer 2. And again, it's going to point into, you know, if it's true, do index 0. If it's false, do index 1. Which is then going to, if it's true, we'll execute this. And all of a sudden, we have to create a new DOM fragment, create a text node, append them together, create a comment, create a text node, build render nodes. You can see for the recursive case, all this extra stuff we have to do. Also notice the difference between, like, really what we want to do here, or even if I bring it back to here, right? Hi name. Again, we have this 3-stage strategy where we create the fragment, put in some text, create an empty comment, and then we create up the morphs, and then we execute the statements. When really all we wanted to do was append hi and then append Ben, right? That's the, if we could do that, it would make initial render fast. And on the update, all we need to do is update the Ben if it's changed. And that's exactly what Glimmer 2 is. Okay, so we've done that. I created a playlist today of some of the videos that I think would be useful if you're interested in the internals. They're very useful for me. Some of them I recorded with Yehuda when he was either over in Intercom a year ago, or I met him in London a couple of months ago, and these are in-depth dives into all of the details of, you know, his thinking and actually helping build this thing. So the first one is on Glimmer 2, which was a couple of months ago. This one, HTML bars deep dive, this was a week after he had started thinking about how he could come up with a new strategy. And actually it's really interesting because there was no virtual machine, there was no TypeScript, but all of the primitives that are in play now, or most of them, the significant ones, he described them in this video, which is really amazing, I think. Himself and Godfrey, who's also been, I guess, the main 4 people who've been working this have been Yehuda, Godfrey, Chad, and Robert Jackson. And Godfrey and Yehuda gave a keynote at EmberConf last year where, again, they went into a lot of detail. They focused more on the reference system and the tagging system, so a way of modeling the data hierarchies and a mechanism to pull the data off as you need it. So another really great, interesting video. Godfrey also had a good video on what's a compiler and some interesting things there. And another video from the EmberConf last year was James Kyle, who gave this great talk on how to build a very minimal compiler, parser, all of that. It's like basically a very simple programming language. And it really, this to me really opened my eyes to how simple this stuff is. And I think you can appreciate that it's an ambitious thing to build something like this, but on first look, I hope you could follow some of it, and that's a testament to actually how simple the thing is. So, thank you. So hopefully someone has got a question. Yeah, so the question was, how will this help mobile rendering performance, which has been problematic. So I guess all of the ways that this will make improve performance on the web will benefit Android as well, right? So if the templates are 30% of the size on gzipped, they will be the same for Android, right? So you'll download less, you have to interpret less. The effects will actually be bigger because the relative slowness will, the duration will be, the amount of seconds saved will be greater, right? This is only the beginning of, this is something that unblocks a whole new strategy for Ember for mobile specifically. Glimmer itself, as you can see, contains a lot of concepts that used to be just in Ember itself. So there's actual runtime, and there are things that look like components. There's a reference system that allows you to do computer property-like things. Glimmer 2 has a lot more, but a lot of the mechanism that was Ember, that was in Ember, has now moved into Glimmer and is much faster. So Glimmer itself, now it becomes possible to build a React-like app with just Glimmer without computer properties, or without, with a very simple component definition, or like if you wanted to aim for raw speed and reduce payload size when considering the framework and your application all bundled together, and like that space and time, and it's all at a premium. Glimmer is at some point going to be an option there. So I'd imagine that at some point next year that there will be a strategy for it. You can create an Ember app using Ember CLI, which will be low-level Glimmer, right? And you will be able to create mobile apps with it like that. They will be HTML mobile apps, but the interesting thing about Glimmer and the runtime is you could quite conceivably create a mobile runtime, a virtual machine that takes those same opcodes and drives a mobile, a native UI, right? And that's going to be really interesting, and like huge possibilities there.
Just on top of that, then, like, would they still be recommending some strategies like around smoke and mirrors, and which I think fell that day that they talk at EmberConf, maybe around these type of issues?
Yep. So Smoke and Mirrors and I guess Ember Collection, the two of them aim to solve a particular problem, which is universal in all applications, but it's more acute in any application that's slow, and that is rendering large lists. Rendering a lot of DOM is slow, right? It scales linearly. If you're going to do 1,000 DOM elements and you want to do, now you do 10,000, it's 10 times slower. So if you have a large list of things, you want to render them, that can be expensive. So I think the ceiling for when that gets expensive is going to be it's going to be better much better with Glimmer. So a lot of the cases where you would have had to resort to using something like Smoke and Mirrors or Ember Collection, you may no longer need to, because the problem won't be as bad, right? You'll just all of a sudden it's okay to render, let's say 300 list items or whatever the number is, where maybe it was only 100 before. But obviously you could have a collection of 10,000 things, and that's still going to be slow depending on what each of those are. So I think there's always going to be a need for mechanisms like that will allow you to render a large list of things, or appear to render them, but actually you only render what's visible. So for anyone who doesn't know, Smoke and Mirrors and Ember Collection allows you to give the appearance of rendering a large list, and as you scroll through it, it looks like the list is scrolling through, but really what it's doing is just, it's got a window where it renders those DOM nodes. And as those DOM nodes go outside the window, it uses CSS. Certainly this is how Ember Collection works. I guess Smoke and Mirrors does something similar. It uses CSS to translate it back down to the bottom and changes the data in it. And then as you scroll up, it appears to be this list that's been rendered, but you've only rendered a small portion of it. So it's a lot faster. Thanks. Yeah?
How is that crash going to do? How big is it going to get? How does it
the cache.
Yeah.
So I don't think it's going to be significant. So it's going to be, so first of all, a mechanism like this already exists in Ember, right? Computer properties, for example, and the underlying implementation of those keeps around caches of values, right? So if you have a computer property, full name, for example, it keeps a cache of that value, right? And it's got, I guess, also got subscriptions and things like this. There's a whole set of bookkeeping that has to sit around that, the actual value that comes out of it. So, and then of course you also have the value in the DOM, right? You should render that stuff. I don't know it, like comparatively if it's going to be better or worse, but my feeling is it's not going to be significant in any way, right? That it's very cheap relative to the DOM nodes you're creating or other things in your application. I don't know how to answer it more than that. Okay. Thanks.
The other question, we get the Visual link back again.
Yep, of course, and I'll tweet as well. Mm-hmm.
You started by saying that Glimmer formed from HTML bars.
Mm.
What are the evolutions within HTML bars? What, like today, you just presented it like as a state, but what do the HTML bars guys think is the way forward? Like, is there anything interesting in their evolution?
Right. So HTML bars and the Glimmer guys are all the same guys. If you notice the like Glimmer is a Tilde project, and Tilde is the company founded by Tom Dale and Uta Katz and others, and many of the core team work. Well, it's been replaced by Glimmer. So right now in Ember 2.8, we're running HTML bars. So it's the rendering engine, right? And it also has the name Glimmer 1 because there was like a progression with both HTML bars and the Ember framework itself that became Glimmer 1, but the two of them work together. Glimmer is a complete replacement for HTML bars. So, right, so...
I was just curious if there was like a bunch of enthusiasts that were trying to keep it going themselves.
No one wants to keep HTML bars going because Glimmer is just so much better, right? It's like even like it's represented in the colors, right? In the like that's the old way, that's the new way, right? It's better. All right, thanks a lot.